Hi everyone. Uh, Welcome you guys to the chapter 3 of AI performance engineering. So last chapter we discussed on what all the roles in benchmarking and profiling the AI system performance engineer has. Today we will be discussing what all the roles he will be playing in scaling distributed training and inference. Yeah. So let's get on to things usually what he will be doing is so he will be scaling the workloads from 8 GPU to 80,000 GPU clusters without getting the overhead and maintaining that efficiency. So that is one job he will be maintaining, and the next is optimizing the NCCL, NVIDIA Collective Communication Library. Let me explain what is NVIDIA Collective Communication Library in a simple terms. So let's get on to the depth in the later chapters. So super simple explanation is, imagine you have a four GPUs in your computer, and think each GPU is considered as a student, but sometimes you need to share. Okay, so students has to do the homework. Homework is a task. So what they have to do is they have to combine, means they have to take small part of the homework. Each of the student will do the small part of the homework, and then once it is everyone done, they have to combinedly add this homework and pass it to the teacher. So the teacher will say what part of the homework to be done by what student. That teacher is called NCCL library. And so imagine, for example, you have to count the apples which are in the room. So there are 20 to 30 students. They think students as a GPU, and counting the apples is a task. So now each student will take a different task of counting apples. One will take at the left side to count, and one will take at the right side to count. One will be counting which is on the table. One will be counting which is under the shelves. Once everything is done, they will add them all, and they will give you the final output. So this is one of the method called all reduce in NCCL library, and there are different kind of methodologies to do the task. One is all reduce, one is broadcast, one is I think there are plenty of methods. We will get into the next chapter. So optimizing this will be the one task for him, and there will be thing called NVIDIA transfer library. So he has to optimize this NVIDIA transfer library. What is this NVIDIA transfer library? Let's understand. Let's say if you do some task in any web or anything, so what it has to do, it has to send, means it will be working in the CPU, that has to send to GPU for processing, and it has to receive back to from the GPU to CPU again. Okay, so now what is the use of it? Okay, now we have to run it faster, correct? So it has to run it faster, and it has to use less GPU memory, and it has to load quickly. So when we
Hi
are
everyone.
transferring the welcome you guys to the chapter 3 of AI performance engineering. Sorry. Yeah. Whenever yeah, so I was saying, so whenever we want to communicate between CPU and GPU, so what we have to do? So we have to exactly maintain the data efficiency or the speed over there. So that's fine. To maintain that, we will use the NVIDIA transfer library. So we have many tools like that, which NVIDIA developed. That in that one is called NVIDIA inference transfer library. This is for AI model to process faster and send the data back to the CPU. Okay, it helps you to send data, images, audio, text into the GPU fast, and return get back the AI output fast also. It's like a fast courier system. Optimizing that will be a task. And also the last job will be placing nodes and choosing the parallelism. So what is placing the parallelism means, I will tell you. So I think so there will be different tasks accordingly, right? So for example, so there is an analogy where imagine you have a very long book that your teacher wants to class to read to summarize. Okay, or think in the software terms where you want to process an image or generate an image. Okay, so you can choose different parallelisms. One is data parallelism, where the data is huge. Okay, so the GPU can't, the single GPU can't take all the data. So what it will do is, means what they will do is each GPU will take small amount of data, process it, and give the final output. Once all the GPUs have done the work, then they will combine it and they will give the result. That is one part. And some will means let's say now the AI model is very big, and you can't means you can't put one model in each GPU. So what you will do is each model part will be placed in one GPU, and a certain amount of job from that means can be done with only one that of small part of the AI model. So like that, they will divide the task and they will give the final result. That is called tensor parallelism or model parallelism. Next is pipeline parallelism, where so AI will be run via pipeline. So one after the other task will be passed to one GPU. This one, that's called pipeline parallelism. Next is expert parallelism. I think you maybe heard of the Stat GPT and Claude. They will be talking about MOE, mixture of experts. Okay, so one is expert, one is English experts, etc. So based on this expert, this one, each GPU will be considered as each GPU or GPU cluster will be considered as an expert parallelism. So where certain amount of task will be fed to that expert GPU, which will process the task and give back to the user. Okay, this is called expert parallelism. So placing these parallelism, which one is better, is also the AI performance engineer job. Yeah. So let's meet means to learn about managing resources efficiently and transparency and reproducibility in the next chapter. See you again. Bye bye. Take care.